I just want to check in one more time regarding quizzes and late work for in-class learners and distance learners. I still have people emailing me, kids in this class, kids in every class, asking what they can do to raise their grade and if I'll reopen quizzes. Am I going to extend the quiz window? No. If you're a distance learner, you can't see, but half the kids in this classroom right now are saying no. I am not going to help any of you go from an F to anything but a D minus. If you can get your work done, great. I will leave the lessons open for you guys to finish those. You can still take the Unit 4 exam. I won't let you fail the class, but I'm not bending over backwards so that you can get a C or a B or whatever else it is that you want. So I hope that I've made that clear. I don't want anybody else emailing me. If you need help, come and talk to me. If you feel that strongly that you deserve an exception, you need to come and see me in person and talk to me about it. But even if you come and talk to me, I'm not extending any of the quiz windows. You can see, hopefully you've at least looked at the new calendar in Canvas. So if you look at the dates that we have until break and even after break leading up to your Unit 4 exam, I've taken off all of the quizzes. So the last quiz that we will have for this unit was quiz 43, and I've taken them off because I think that the questions at the ends of the lesson serve the same purpose, for me at least. And at least on those lesson quizzes, you guys can redo them if you want. You have 99 tries to redo them. I like the lesson quizzes because I can see where you guys, I can see how many of you have done the lessons. But also, I just think that it asks the same questions and serves the same purpose as the in-class quizzes. But I think it's easier for both of us to just do the lesson quizzes. Does that make sense? So I would try moving forward to get a good score, but as long as you do them, it'll just be a completion score. You should probably get more than 25 though. If you are getting less than 25, I'll probably reach out and say, you should really redo this lesson quiz. But as long as you are getting, a decent score, I'll just give you 50 out of 50. Any questions on that? No? Okay. So last time we did residuals and residual plots. You guys had a little bit of time to work on your can you do in class. Were there any lingering questions from the can you do or anything that we did in class? I'm hoping that we will have time again today to work in class on some of our stuff, especially if we're not quizzing today. These 2 lessons that we're doing are relatively short and straightforward. So I'm hoping that changing the format will give you guys some time to work in class. And if you're working and you realize that you have a question, just grab me if I'm walking by or raise your hand and I'll come over and help you. Otherwise, today we're doing, there's 2 parts to this lesson. We're talking about these, I guess you would call them summary statistics. Linear regression has 2 pieces of information that are really helpful to us in terms of knowing how well regression fits a model or a relationship between 2 quantitative variables, and those things are R squared and S. You'll want to be careful to note that R squared is called the coefficient of determination, and R is called the correlation coefficient. Sometimes they don't give you the letter, they just give you the actual name of the symbols, and mostly with R. So R, we need to make sure that we're okay with the idea that that's the correlation coefficient and that R squared is the coefficient of determination. and they are related. So we can fill out this top part now. R squared is literally R times R. And you always write it as a percent. If that's the case, if it's literally R times R, the reverse works as well. That means that R is equal to the root of R squared. Actually, I need to add something on there. It's plus or minus the root of R squared. So this top part, this very first sentence, by the time we get to the quiz, you're probably going to forget this. You're probably going to forget that it's R times R. So I would maybe make a little star and write quiz. Because one of your questions on the lesson quiz, you'll need to remember that R squared is literally R times R. And that's the R that we've already been talking about. So we'll go through what these two things mean, R squared and S, and then we are going to see how influential points affect R squared and S. So we've already kind of talked about influential points, and we're going to revisit that today, adding on the new information about the core coefficient of determination and S. Okay, so back on this page, R squared is always written as a percent, and it is the percent that describes how much of the variation in Y is explained by X. And I will explain that further. It is how much of the variation in Y is explained by X. So I'm not sure really how much we've discussed variation at this point, except for to say that for a quantitative variable, variation is how spread out your data is. And as we move through the rest of this year, we start to talk about how variation describes this idea that if you're looking at two variables, there will likely be differences between the response variable. So I'll explain that a little bit, hopefully a little bit more clearly. If we are looking at let's say the truck example where we're talking about how much a truck costs based on how many miles it's been driven. If a truck has been driven 80,000 miles and we recorded an actual value of the sell price being $29,995, does that mean that every single truck that has 80,000 miles will be about $30,000? No. In fact, our model, which is a good model, is predicting a price that is lower by 4,000. This is what they mean by variation. In real life, if you have a truck that's 80,000 miles, and you get a price of 30,000, that doesn't mean that every single truck will be 30,000. There will be some differences in the price, and the R squared tells you how much of the difference is explained by your miles driven. So we'll have different prices for the same miles driven. How much of that difference in the prices is accounted for by the number of miles that it's been driven? That's like this underlying understanding of variation. It's that if you're taking a sample, like you're asking kids questions, and you're asking, how many of you guys think that we should cut Christmas break short by 2 days so that we can get out of school a week early? some of you guys are going to say, yes, let's cut Christmas break short. And some of you guys are going to say, no, I would rather have the 2 days now and suffer in the end. That's variation. Not every single person's going to answer the same. Does this make a little bit of sense? Okay, so variation means there's going to be differences in your response variable, and how much of those differences are accounted for by whatever your explanatory variable is. The interpretation of R squared then is trying to describe that. So this says interpret the R squared for the attendance and test score data. So the last thing that I put in my calculator was the residual plot on the previous page. So it was this data to find my residual plot, which means for me, that data is still in my calculator. So I can run the linear regression on that for us. And now we know the one other element in this list of numbers. We now know what it is. So this will give you your R squared. It gives us your y-intercept, your slope, your R, your correlation, how strong is the relationship between the two variables, and then it gives you your R squared. How much of the difference in price is explained by the miles driven. So I can write here that we have an R squared of 0.95. I'm just going to write the whole thing just for my reference, but I'm not going to write that whole thing, sorry about that, when I interpret. While you guys are writing that down, I just want to plug in, so R was 0.90. I just want to plug that in and square it. Did I get the right R? Nope. This one. Oh, R is 0.95. Well, let's hope this works, family. So I just want to show you that R squared, 0.95 squared, really is equal to R squared. That sounds dumb to say, but there it is. Okay, so here's how we interpret this. Hopefully it's very straightforward for you. 95, did I write down the wrong number? Ugh. I like that some of you guys had faith I was going to figure it out. It's really 903, 429, 0211. And I'll write a note to myself that that's from my calculator. Okay, sorry about that. So what I'm going to write here is just the percent. If you need to, times it by 100, or otherwise move your decimal 2 to the right. So 90% of the variation in the end of year Algebra 1 exam score can be explained by the percent of days attended when using the LSRL. I'll explain what that is after I give you a second to fill in all that info. Give you about 15 more seconds and then I'll read it as one fluid sentence and explain some things. About 10. Three. 2. Okay, so 90% of the variation in the exam score can be explained by attendance when using this LSRL. Some of you guys picked up on this in the last lesson quiz in the Can You Do. The regression line that we've been finding is called the least squares regression line. And that is actually the next lesson that we do. The next lesson explains to you why it's called the least squared regression line. So because I know that's coming, we're just going to add that in now, and you can abbreviate it as LSRL. You could think about variation as the difference. You're going to want to use the word variation though. And I was super extra on these variables. You could have just said exam score and attendance. So as long as your X variable and your Y variable are correct, all of this extra detail is not going to get in the way of you getting full credit or not. Is that making a little bit of sense? So 90% of the difference in the exam scores can be explained by the attendance when using our model. So that's a lot. That means that when we look at our residual plot, we should see no pattern, little pattern left over if a linear model is appropriate. Are you guys okay with this idea? Okay, you once in a while will get asked this variation right here. If 90% of the data can be explained by attendance, how much of that cannot be explained by attendance? 10%. So often I see on the multiple choice that they will give you either R or R squared and then ask you how much cannot be explained, and you get it wrong because you're so used to seeing how much can be explained. So you want to be careful to know that this is like a two-way street. If 90% of the difference can be explained, that means that 10% of the difference in scores cannot be explained by attendance. And then this box right here is just your phrases to memorize. So you can use this framework if you prefer when you go into your lesson quiz to interpret R squared. So before we move on to the next one, I just want to recap. R is the strength of your relationship. R squared is how much of the relationship, how much of the difference in Y is explained by X. If one of them is high, the other one is also high. You'll never get a large R and a small R squared or vice versa because they're using the same number. Is that making a little bit of sense? Is that a yes? Okay. So then the other part, or the other thing to talk about in this part of the lesson is this number called S. You cannot calculate S, and your calculator does not calculate S. This must be given to you. S must be given to you. You're gonna go online and do some regression on using an online calculator or program. and it will give you S, but our calculators won't. So on your exam, you'll probably always be given S because you will just have your calculator to work with. So S is the standard deviation of the residuals. S is the standard deviation of the residuals. So previously, we defined standard deviation as the typical, which is the same thing as average. The typical or average distance from the mean to each data point. So a smaller standard deviation is better. How far away are the other points from your average value? Well, the standard deviation of the residuals, gives the approximate size of a typical prediction error. This will make much more sense, I think, once we do our first interpretation. So it is, S is the standard deviation of the residuals, meaning it is the average distance of your, so this is going to be complicated, maybe I shouldn't tell you, but the residuals have an average size. So it literally is how far away are your residuals from the average residual, which sounds complicated, but when we look at the interpretation, I think you'll feel better about it. So in other words, it is the typical distance between the actual Y value and the predicted Y value. So if you had to memorize or understand what S is, I would just focus on this box. The standard deviation of the residuals gives you the approximate size of a typical prediction error. So what does that mean? Let's take our Ford truck example. The S for our Ford truck example is 5,740. Interpret the standard deviation. So what that means is our predictions will typically be off by about $5,740 from the actual sell price of a Ford F-150 when using the least squares regression line. So our predictions will typically be off by about $6,000. So we might be $6,000 above or $6,000 below, because we know based off of this scatter plot that we're not going to predict the price exactly for hardly any of our trucks, but we can be pretty close. And on average, we're within $6,000, either above or below the actual price. On our one problem, we were pretty close. This one was only off by $4,500, but our average error is about $5,700. Is that making a little bit of sense? So this one is our phrases to memorize here. So R squared is going to tell you how much of the difference in Y is explained by X. And S is going to tell you how much our predictions are usually off by. So I would imagine that doing a couple of problems would help you understand a little bit better if you have questions on this. So if you go in now to Canvas, you can try, I think there's only 2 for this part of the lesson. You can try the 2 problems that have to do with R squared and S. Give you a couple minutes to try those. Okay, if you're at home, pause the video. I'm going to pause my video and then come back when we're ready to go on to the next page. Now revisit the idea of influential points. So this is the last part of our lesson, which means that I should stop this one.